This is a rapid fire round. If you don't want to answer a question, you can just say pass. At what age do you want to retire?
I don't know, in 2 decades, maybe.
What's your favorite mobile app?
Google Maps, probably.
How long does it take you to get ready in the mornings?
10 minutes.
Most embarrassing moment of your life?
I don't know.
Pass then. Mountains or beaches?
Beaches.
What's the most useful mobile feature you can't live without?
The internet.
Favorite color?
Blue.
What time of day are you most inspired?
Early afternoon.
How many hours of sleep can you survive on?
7.
Fill in the blank. An upcoming marketing trend is blank.
Influencers.
The city in which the best kiss of your life happened.
Pass.
Pick one, Android or Apple.
Probably Android.
The biggest mistake of your career.
Pass.
How many cups of coffee do you drink per day?
3.
How do you relax?
By sleeping.
A habit of yours that you hate.
A habit of mine that I
Hate.
hate. Working too much.
The most valuable skill you've learned in life.
Never give up.
Cities or countrysides.
Cities.
And the last one is your favorite Netflix show.
I cannot remember if Black Mirror was on Netflix. I don't think
It is, yeah.
Black Mirror.
Well, that's the end of the rapid fire round. These other questions are long questions now, and you can answer them with as much ease and time as you like. The first one is, with the increasing use of AI and machine learning in the telecom industry, what are some new privacy risks that users may face, and how can we mitigate them?
Right. So, I mean, if I take in general AI, not specifically for telco or not, I would say that there are several challenges that have to do with attackers trying to kind of reverse engineer your data or your models that are being deployed. And this depends on where the attackers are, if they're in the network, if they're on the servers, if they're on the user devices. And then the types of attacks can be trying to reverse engineer your data, trying to understand what properties the model has. Now, what we can do about it is we have these different, let's say, techniques or methods that you can modify the model when you're training these machine learning models. You can, let's say, influence the model to not learn exactly the data of the user. And therefore, if an attacker tries to infer something about the user data, they will not be able to distinguish. They won't be able to understand exactly. Now, as you understand, it's always a trade-off between privacy and how good a model is. So, if you are suspecting that your infrastructure or your AI models will be attacked, you have to protect them with more severe methods, which may have problems with respect to scalability of the models, and might have problems of utility, like how good the models are. So it's always a trade-off between the two.
A balancing act.
Yeah.
So with the rise of 5G and 6G networks, what are the biggest security and privacy challenges with those?
So what I'm expecting is that with 6G, we will be seeing a lot more, so we will have more sensing of the users and the devices that they're using. We will have smart buildings. We will have so many things that are sensing the environment and us as well. being inside these environments. And therefore, I'm expecting that moving beyond, the, let's say 4G, going 5, 6G, users will need to be definitely much more educated and aware that there is a risk of privacy, right? Just think about the scenario of you being more easily localized, no? In 6G, there are technologies that will be able to understand where your hands are, We're not talking about like where you are as a person, we're talking about, So we are expecting that we will have this type of capabilities, and therefore it increases the challenge of how do you protect this property of privacy. And what people are suggesting is that we do that at the physical level. So we shouldn't be expecting, or we shouldn't wait for the data to be collected and go into some servers or whatever and then analyzed. We need to protect the user from the point of view of privacy security at the moment when the data are being created. And that's why we are proposing also various methods that are more what we call distributed privacy preserving machine learning methods, where you do these things at the edge or even at the user device, and you try to protect these properties at the source.
And in what ways can AI be used to enhance cybersecurity?
So one way to think about it is that the AI is a powerful, let's say, tool, right? And we can use it to protect the user's privacy and the security by detecting such attacks, right? So in the same way that an attacker can try to attack a model and try to understand if I am here, if I'm there, and so on, I can also have an AI module trying to detect the attacks. So it's a very, very powerful kind of a tool to do. You can detect anomalies in the network that in the past, were done with heuristics, with manual rules and stuff like that, which are very rigid. They cannot be adapted quickly, right? So with AI, you can, of course, given the access to proper data to train the models, you could build these powerful tools that can detect the attacks, can detect novel attacks when there are some anomalies. So there is this duality of the thing. It's not just bringing, let's say, bad things, right? It also brings this power to both the users and the providers.
So, and how about blockchain? The emergence of blockchain technology has been hailed as a potential solution to data privacy concerns. How do you see blockchain being used in the telecom industry to protect users' privacy?
So the way I see blockchain is blockchain technology is, let's say, you're having some sort of distributed ledger that tries to keep tabs of things, access to data or something like that. Now, the way I could see it being used is having some sort of blockchain technology that allows a couple of things. One is keeping track of who is accessing my data, who is trying to share my data. This is done through these decentralized kind of ledgers that have these immutable records, so nobody can modify them. So if you decided to access my data, I will be able to know. Also, you can use blockchain technology. There is this concept of smart contracts, and all these things that I just mentioned earlier can be dictated by smart contracts. So there are these, let's say, tools, these automation methods that blockchain technologies can offer. And the smart contracts, then you can audit them, you can check down the road. For example, governmental agencies, they want to access my data. I will be able to audit who accessed them, when, why. So there are records, right? And nobody can touch them. At least that's in theory. Yeah.
So as telecom companies roll out new 5G infrastructure, what challenges do they face in terms of deployment and scaling, and how do they face them?
Well, what I see is that we have this, for example, for 6G, right, 6G, we will be seeing a much larger scale of a necessity of large scale infrastructure, right? I mentioned earlier about the sensing, all these things that requires infrastructure. What does that mean? Is that you need also some way to manage these resources, no? And if you don't have some sort of automated way to do that, you're going to fail, right? So AI can help you basically solve this challenge that comes with going into 6G. Cybersecurity-wise, again, I mentioned earlier that whatever challenge comes with, you can sort of solve with the AI. We also have this opportunity for doing the what we call resource management, reallocation of let's say bandwidth or of network infrastructure, because you can use it as a service. We have this concept program with Telefonica Networks as a service. There will be in the future a security as a service. There will be all these concepts of providers that could be for markets, it could be for infrastructure. So all these things can allow not only the telco operator but other industries to capitalize on AI and solve at the same time these kind of challenges. And last thing, there is a concept that we call software-defined networks that has been around for a while, of course, is the way of abstracting the network as a software and kind of mix and match type of components that you need based on the expected utilization. So, for example, we are in Mobile World Congress now. This doesn't happen often. It happens only once a year. So that means that during this week, you need much more infrastructure close to support, hundreds of thousands of people being. So either you're going to deploy manually a bunch of antennas and all these things that need to support the users, or you're going to abstract the infrastructure at the software level and shift around resources to support these users. And this, you can envision it, I said, for the Mobile Congress, but you can envision for any type of activity in the future.
And so how have you addressed issues of bias and fairness in your work on data mining and machine learning on large-scale data? Can you describe a specific example of how you mitigated bias in your models?
So this is actually an area that I'm entering now with some colleagues. I know that we have this ongoing research on understanding fairness and bias with respect to different pipelines that are happening in Telefonica. But beyond Telefonica, I think there is this concerted effort by the research community to invent new methods that allow you to train a machine learning model that is more fair and less biased. The way usually to do that is to make sure that either your data is not biased, which means that you need to have some sort of balanced set of data across all your labels, across all your properties, or if that is not possible because of the data collection process, to counterbalance this in the learning, in the model training. So to give you an example, if you are trying to collect data, census data, right, across Spain, right, but there are some areas that are very difficult to reach, right? So those areas may end up being underrepresented in the data set, right? Now, if you have an expectation that this is going to happen and you can anticipate for it, you can also plan some sort of weight to counteract it inside the learning, right? And we are examining all these different methods to make sure that whatever model we build on user data or infrastructure data are representative, are unbiased, they have this balance across labels and so on.
The next one is about, can you discuss your research on streaming graph analysis? What are some of the key challenges in analyzing graphs in real time, and how have you addressed them?
Yeah. So this one is definitely some work I did in the past, and I would say that the big challenge with processing or learning on big graphs is two issues. One is the scale, and one is the dynamicity of the graphs. So when you're talking about, for example, social graphs, if you want to analyze the real-time graphs, these are constantly changing. An example of a social graph is friendships. So the Facebook graph, for example, people are becoming friends or unfriend each other all the time, right? Now, if you want to study this type of graph and have an up-to-date set of metrics, like who is the most central in the network, or give me the top 1,000 central users. This may be changing constantly. So your methods, your graph analysis methods, need to be able to adapt to this property. Then you also have the problem of size, right? If you're talking about like a big graph, like the Facebook graph is a few billion users graph, you may not be able to fit it inside one machine, right? You need a supercomputer to actually fit it. So you need to come up with clever ways to process maybe portion of the graph at each time, and perform computations to make it possible. So to back to your question, in the past we worked on some, let's say, difficult centrality metrics, and we invented some methods on how to compute and recompute these metrics at almost real time while the graph is changing. And this was the challenge. Like, how do you find a way? I don't need to maybe mention too much in detail, but yeah.
Okay. And how have you approached workload analysis on distributed stream processing engines? Can you describe a specific example of how you optimize the performance of a system under heavy load?
Yeah, so we did this work. It's been also a few years. The idea is to first of all, to accept the fact that in heavy workloads, not all the data are coming in at the same time in the same rate, So there are some data that are more popular than others. For example, if you look at Mobile World Congress at the moment on Twitter, it's going to be much more popular as a keyword or hashtag than, I don't know, a random village in Catalonia, right? They're both kind of happening in Catalonia, but one is much more popular. Now, if you want to process and do some sort of computation, some processing on these specific hashtags, one of them will be much more popular, so that means that you need much more computing power to do it. So some work we did there was to find a clever way to redirect, let's say, the incoming flow of traffic coming for specific keys or keywords that are very, very popular and distributed across many machines, right? So the scenario there was that if you have this type of unbalanced type of data set and you need to process it at real time, how do you do that without killing specific machines because they're just getting all the load? So there was this scaling and rescaling type of technique.
Okay. And the kind of overarching question is, what are some of the most exciting research questions or areas of inquiry in your field right now?
Well, I mean, it depends if we talk about the computer science in general or if we talk about my field. I think in my field, I'm focusing on security and privacy in AI and the web. We have these techniques on privacy-preserving machine learning. We are looking to federated learning. So I'm doing a lot of work on that, and I think it's one of the very, very promising ways to train AI models at the edge, the user's devices, and so on. There are, of course, the things that I mentioned at the very, very beginning, adversarial attacks, and how do you detect them? How do you protect the users from this type of attacks? Then there is, if I kind of step away from the security and privacy, I think there is the general concept of quantum computing, which is becoming more and more of a reality. People are looking into it much more, as well as something that's also relevant to 6G, which has to do with coming up with ways to communicate between point to point in a very, very fast way. We are talking about reaching terabit type of speeds. There were some reports recently from China, I think, that they achieved it, but we're talking about having it in a production level. We're still experimental. So figuring out how to do this high bandwidth and low latency type of communications. And also the infrastructure point of view, so edge to cloud, and how do you move computation from the edge to the cloud and back and forth. So we actually have some projects that are, let's say, focusing on figuring out that, because the traditional way so far was, okay, let me collect everything to the cloud, compute it there, and then maybe I'll send to the devices. But people discovered that you cannot do that. It is not scalable. So let me push something back to the edge. So there is this edge to cloud type of new way of thinking, no? And that means there is a lot of research to be done at the edge to understand what we can do, how we can optimize the training of the models. There is a lot of work to be done how to optimize computation at the cloud, and this moving back and forth, right, to orchestrate this workload.
Okay, so the last question is more of a personal kind. What would you be doing in your life if not this right now?
Probably singing and dancing.